Hello, once again. We are presented now with a problem on matrix algebra, that of determining some conditions under which this 3×3 real matrix is singular. But at the moment that I was presented with this problem, the first thing that came to my mind is, well, why don't we use the power of determinants to help us in this problem? So our sidekick will be the cofactor expansion of such a matrix function, the determinant. Now, what I'm doing here is maintaining some freedom because there are several cofactor expansions. In fact, one for every column and one for every row. So at this moment, what we're going to do is take advantage of the one that is more favorable for us. So what could be that? Well, I would say something along these lines. Look, it seems like most of the information about A is located in this column. So what I'm going to do is expand the determinant along the first row, meaning I'm going to leave J fixed, J1. So in our case, we fix J to be 1. So now the determinant of the matrix that we have here, that I'm going to call A for a second, right? For simplicity, so that we can continue with the computations. I'm going to say the determinant of A is the following expression. From I running from 1 up to 3 of -1 to the power of I plus 1. Remember, I'm leaving J fixed, the first one. A, I, J, M, then 1 here, then I, J, but of course, this is a 1, right? Now, some explanation. The element that we find here is the entry associated with the matrix. And this one is the minor, meaning the determinant that we get from the matrix obtained by removing the ith row in the first column. So I'm going to expand this a little bit more because for our case, we get the following. This has to be, well, -1 to the power of 1 plus 1, A, 1, 1, M, 1, 1, plus -1 to the 2 plus 1, A, 2, 1, M, 2, 1, plus -1 to the power of 3 plus 1, A, 3, 1, M, 3, 1. Of course, we're going to simplify a few things, and this becomes a 1, and this becomes this entry. So I would write this as A times the determinant of, I'm going to remove from this matrix that I have here, the first row in the first column, and I will get just the following. -7, 4, -6, A. Now, minus A times the determinant of the matrix that we get by removing the first, the second row, and the first column. So what will be that? Well, I'll look into here and let's see what is that I need to remove. So I remove this row, right? And now I also remove this row and I remove this column. So I'll get the following. 4, 4, -6, 8. And lastly, I have plus 8, the entry associated here. And then, well, I'm going to move this dotted component here so it becomes a little bit easier for us to see what is that we need to remove. So this is indicating that I have to remove the third row and the first column. That means that I need to get rid of all those entries. Okay, so I'll do it. I get the determinant of 4, 4, -7, 4. Well, at this point, it's just simple computations. So what is this? This is A times -7 times A minus -6 times 4 minus A times 4A minus -6 times 4 plus 8 times 4 times 4 minus -7 times 4. Now let's do some reductions here. Algebraic. So we get -7a squared. This becomes positive 24a plus 24a by distribution. This becomes now minus 4a squared plus 24, but with a negative here, so minus 24a. And then, well, here, look, we have in common a 4. This becomes a plus. So you have 7 times 4, but also 4 times 4, that becomes 11 times 4. So what I have here at the end is plus 8 times 11 times 4. I'll keep the factorization just in case that it becomes handy as we progress. And well, some elimination. Look, the terms that we have here are identical, but with opposite signs. These two have common a squared. All that I have to do is to combine them. So I have -11 a squared plus 8 times 11 times 4. Oh, so this time it was handy to keep the 11 because now I may factor it in this fashion. So -11 times a squared minus 8 times 4. So you may say, well, what does that have to do with singularity? Well, recall that an n by n matrix is singular if and only if its determinant is 0. So in virtue of that knowledge, we can say, oh, look, all that I need to do is establish some conditions so that this number is 0, right? So let's find those. So we need to find all A such that, well, -11 times a squared minus 8 times 4 is equal to 0. But this is equivalent as to say that a squared minus 8 times 4 is equal to 0. But also, this is the same as to say that a squared is equal to 8 times 4. Oh, but this is the same as to say that a squared is equal to 2 times 4 squared. And finally, from here, I will just say that a, it's, well, either 4 times the square root of 2 or -4 times the square root of 2. And well, with this, we finish. Those are all the possible values of A for which this matrix is singular. Now, we make then a strategic decision of expanding the determinant along the first column. Why? Because it seems like that's the one that contains the most information, and it would involve a complex manipulation within the determinant, only in the entry itself. So in this time, that decision paid some dividends, and in the form of a very simple solution. Okay? So I hope that you enjoy it. Let me know if you'd like me to do more videos of this kind, and well, subscribe.